So, hello, first of all. I know it's been a while since you guys have heard Mrs. Zarobsky do a lesson, so I thought instead of assigning Khan Academy for a substitution method, I would do a screencast. So, first of all, when you guys did those Khan Academy assignments, most of them looked at solutions to a system using graphing. And a solution is really just when you have two lines that intersect at a point. That point ends up being your solution, okay? But in most cases, graphing isn't generally the best solution or best method to solving because we don't have graph paper available all the time. Plus, you also saw that when there was lines that intersected at kind of an interesting place, it was more difficult, to find the solution, and so you had to approximate. So we're going to talk about two other methods, the substitution method and the elimination method. So right now we're going to talk about the substitution method, okay? And so the substitution method works best when one or both of the equations, in one or in both of the equations, one of the coefficients of the variables is 1. Okay, so here's your steps. The first thing is, if we want to solve a system by substitution, we want to solve one of the given equations for x or y. What that means is that, we want x or y by itself. Okay, if this is already done, we're going to move on to step 2. Then we're going to substitute this expression for x or for y into the other equation. So we're plugging it in. Okay, then we're going to solve the resulting equation for the remaining variable, substitute the known value into either of the original equations to find the value of the second variable, and then we're going to check our solution in both equations. So this is your check step. Okay, so the easiest method. This is when you already have both of your equations are solved for y, or they could be for x. But in our case, both are solved for y. So these would be ones that would be typically easy to graph, but I don't have graph paper available. So because both of these are equal to y, they both equal y, that means that these two equations need to be equal to each other. So we are going to set equal. We're going to set 2x plus 3 equal to 6x plus 3. Okay? And that means we're going to subtract 3 from both sides, and we're going to solve for x. So I have my line here, and the 3's cancel, the 3's cancel. So I have 2x is equal to 6x. If I subtract 2x from both sides, I end up with 0 equals 4x, and if I divide by 4, that means that x equals 0. Once you have a value for x, go ahead and plug it in to one of the other two equations and solve for y. So I know that y is equal to 2 times 0 plus 3, which is y is equal to 0 plus 3, y equals 3. So your solution should be 0, 3, because this is x and this is y. And you can check, if you do 6 times 0 plus 3, you get 3, which is what the y value is. So we do end up with the same y value for the same x value. So the solution is 0, 3 to that system. Okay, so let's look at number 2 a little bit faster. So both of these are already solved for y. So we set negative 6x plus 19 equal to 2x plus 3. So I'm going to move 6x first this time because I like positives. And I'm going to subtract 3. So I'm kind of doing two things in one step here. So I get 16 is equal to 8x, because that goes away. Divide by 8, And so we have x equals 2. Choose one of the two equations. I'm going to take this one this time. And so I'm going to do y is equal to 2 times 2 plus 3, which is y equals 4 plus 3 is 7. So my solution should be 2, 7. Okay, check it in the other one. So if I do negative 6 times 2 plus 19, that's negative 12 plus 19 is equal to 7. So I get the same thing. I get y equals 7 when x equals 2. So here's your solution. Okay, so that's the easiest method when they're both solved for y. Go ahead and scroll down with me. I'm going to move past the check step since you're not in front of me. And we're going to look at the medium level. The medium level is when one of the equations is already solved for. So if you look at these two equations, this one's in standard form, but this one right here is in slope-intercept form. Y is by itself. It has a coefficient of 1, which means what I'm going to do is, because this part is equal to y, and I have a y right here, I am going to replace that 6x plus 18 in for y in the other equation. So I'm going to say, all right, I'm going to start with negative 8x minus 3, and instead of y, I'm going to write 6x plus 18. And then I'm going to finish out the 24. So with this, we have to remember our properties of distributing, where we need to distribute first before I subtract. So negative 8x minus 18x minus 54 is equal to 24. These are like terms, so that becomes a negative 26x minus 54 equals 25. So negative 26x, if I add 54 to both sides, I feel like I did something wrong here. Oh, I changed that from a 24 to a 25. I don't know why I did that. Sorry. So this was 24 plus 54. So I get 78. And when I divide by negative 26, pretty sure I get negative 3. So x equals negative 3. Now for this one, you can plug into either of them, but because the second equation is already solved for y, I'm going to go ahead and substitute in that x equals negative 3 into the x in the second equation. And so we get y equals negative 18 plus 18, which is equal to 0. Okay, so the solution should be negative 3, 0. And if I check, negative 8 times negative 3 minus 3 times 0 should be 24. Well, that goes away because it's 0, and this is 24 equals 24, so that checks. So your solution is negative 3, 0. Okay, so looking at number 2, same process. One of these equations is already solved for y. See, this one has the variable isolated. So I'm going to say, all right, so I have this piece here, the negative 5x minus 11 is equal to y. So I'm going to replace the y in the other equation. That's why this is called the substitution method. So I'm going to say, all right, so 6x minus 2 times negative 5x minus 11. Whoops, I did that wrong. I made the parentheses too soon. There we go. Is equal to 6. So 6x distribute. So you get a positive 10x plus 22 is equal to 6. 16x minus 22. So we get equals negative 16. Divide by 16. X equals negative 1. Go ahead and plug it back in. The first equation is already solved for y, and I'm looking for y. So I'm going to do y equals negative 5 times negative 1 minus 11 5 minus 11, y equals negative 6. Negative 1, negative 6. Okay, so that's substitution in its most basic form.